Okay, so number 4 here is asking us to write a function reverse that receives a string and returns a reverse version of the string. So there are a couple different ways that we can go about this, some of which are very good practice, some of which are very bad practice, and some of which are a lot quicker than easier than others. I'm going to start with the one that I think most generally you would probably be able to deduce yourself, right? Which is that we can, we know that if we have a range that includes a -1 at the end, what it's going to do as our step variable here, -1, our step argument, is going to go backwards through the range. So we can do that in the case of our text here, where if we make the range of our for loop here for our text traversal method, we can go backwards through the string, text. So if we go backwards through it, we need to start at the length of the string -1. So ling text -1. And we start at ling text -1 because, for example, if the text is happy, the length of happy is 5. Sorry, yes, 5. But 5 never occurs as an index in happy because it is 0, 1, 2, 3, 4. So if we start at 5, it will actually give us an index error. So we want to start at length of text -1 and then go until we hit -1, which is until we go below 0. And then we want to backstep by -1 each time. So it's going to, in the example of happy, this for loop will initialize our starting location as 4, which is the length of the text 5 -1. It's going to keep going until we get to 0, which because range is an exclusive function, so it excludes its stop point. So we'll stop when we hit 0 or when we would hit -1, and then our step variable being -1 to go backwards to the text. So this should actually be IDX and not character, because technically we're calling the IDX of that is what this variable will stand for. It'll be the index number of whatever we want to look at. And so if we then call text index, what's going to happen is if I put this inside of a print statement and actually ran this, and I can do that really quick. So I can just call it like this, reverse happy. If I run this, forgot to put it in a string. If I run reverse happy, what you'll see is it goes through and it will print every letter of the reversed happy, right? So it'll go backwards like that. Not what we want, but getting close. So we know that it returns YPPAH, which is what we want. Now we need to figure out how to get that added on to a string that we can return. And the answer is that we can use an accumulator pattern where we have our return string and have it be an empty string. And we did a similar thing before when we were building the shapes back in chapter 7, when we were building those shapes, the star, the diamonds, the triangles, the steps, etc. We did this same pattern. So if we have every time through, our return string become equal to itself plus that letter, and then at the end return our return string, we get a function that returns the inverse of that. So that is an accumulator pattern version of this problem. However, that's not great, And it's not great for a reason that we haven't really covered yet. So remember that, or haven't really covered yet. We kind of covered it, but we haven't really dove into it. So remember that strings are immutable, which means that once we create a string, we can't change a string. So really what we're doing every time we are doing this call right here, having return string set equal to itself plus a new letter from the for loop here, what we're doing is actually every time we do this, we're creating a new string. So over the course of this 5-letter word, we're creating 5 new strings, including our empty string that we created in the first place. So modern Python is kind of smart about this in that it handles this memory management pretty well. So if I did like a 5,000 letter long string, it wouldn't like completely crash my computer because it's creating 5,000 new strings to store in memory, right? We have so much memory in new computers, and Python's memory management systems are pretty good to the point where that isn't really an issue, but it's still just kind of like bad form. It's going to lead to a bunch of garbage being collected in memory. There is an easier, much easier way to do this. So let me get rid of all this here really quickly. I can leave the return string. What we can actually do instead is use a clever usage of the slice operator. So it turns out that the slice operator can be used in the same way that the range function can. So for example, if I take text and slice it for 0 to let's say 0 to 5. We'll say 0 to 5. I want to slice the text, and I want to do it at intervals. I want to set my step interval to 2. So if I did that for happy, what I would get is I would get 0, skip 2, 0, skip 1, take the P, skip 1, take the Y. So this would actually return HPY. You can add this extended slice value here after another colon in order to get a step variable essentially for your slicing, which means if you understand how step variables work and how slicing works, so this right here, this slice, means to return the entire string, right? It return the first half of the string and the second half of the string. Our slice indexes are set to 0 and the end of the string. So if we add our step operator colon and then make our step operator -1, what does this mean? It means return the entire text of the string as a slice, but step backwards through it. So this is going to start at the end and step backwards through our string. So if we can just return text blank index -1, it will return the backwards version of our string, and in fact has done that. You can see I'm clicking run and I'm still getting passes. So that is probably the easiest, fastest, quickest way to do this. The accumulator pattern works, it's fine, but the difference is that this is going to always only create one new string, whereas this is going to create as many new strings in memory as you have characters given to it. So again, they both achieve the same thing, but this is going to actually be much faster and is going to cause less garbage memory to be collected inside of the computer.